Come back, continuing local extreme values. Extreme means local maximum or local minimum. Extreme actually means maximum or minimum. All right. So local maximum values or local minimum values. How to detect those? Okay. Now let's look at figure 2 there. You can see here at -1 you have a local minimum. At 0 you have a local maximum. At 2 you have a local minimum. So what are these numbers if you remember? -1, 0 and 2. These are okay. These are obtained by these particular factors of f prime. Okay, if you remember, f prime factors in this fashion. For this factor you got 0, from this factor you got 2, from this factor you got -1. Okay, on the either side of these you are either increasing or decreasing. So what should happen here? You should have slope 0, which is what gets you maximum or minimum. Okay, local minimum or maximum. All right. So now the first derivative test. Okay. So the sign of f prime changes from positive to negative. Now these are important notice. From increasing, you're going to decrease. So that means you have a local max. If you're decreasing first and then increasing, then you're going to have a local min. First derivative test says, suppose that c is a critical number. Critical number means derivative is equal to 0 or derivative does not exist. If you have a critical number of a continuous function f, if f prime changes from positive to negative, then f has a local max. If f prime changes from negative to positive, then f has a local min. Okay. If f prime is positive to the left and right or negative to the left and right, then f has no local max or minimum. Okay. This is better understood using some pictures. Here, f prime positive means you're going up. To the right, f prime negative means you're going down. So C will fetch you a local max. All right. Likewise here, f prime negative on the left, f prime positive on the right. So you are decreasing on the left, increasing on the right. That means C will fetch you a local minimum. All right. On the other hand, look at this story. Here is C. To the left, you are increasing. F prime is positive. To the right, you are still increasing. F prime is positive. So this does not fetch you either a local max or a local min or map, any kind of max or min. Likewise, here is the other situation. Here is C, which has horizontal slope. To the left of C, you are decreasing f prime negative. To the right of C, you are still decreasing f prime negative. So you don't have a local max or a local min. Okay. Now, here is an example. Find the local maximum and minimum values of the function gx this between 0 to 2 pi. All right. First, find the critical numbers. Always you need critical numbers to find cut points, remember. Okay. Now, derivative of x, 1. Derivative of 2 sine x is 2 cosine x. So, when is g prime equals 0? I need to equate this to 0. What does that tell me? Cosine x has to be negative half. When is cosine x negative half? Well, you look at your unit circle if you like, but you will find out between an entire 0 to 2 pi. 0 to 2 pi is an entire circle. You get cosine x negative half means you are on the left, second quadrant and third quadrant. So you have 2 pi over 3 above, 4 pi over 3 below. That's when you get cosine negative half. Okay. Note, your function g is differentiable everywhere. The only critical numbers are these and this. They split your interval from 0 to 2 pi over 3, 2 pi over 3 to 4 pi over 3, 4 pi over 3 to 2 pi. So these are the intervals. Plug in some number here. Between 0 and 2 pi over 3, well, a good number there would be 30 degrees or pi over 6, and figure out the sign. Between 2 pi over 3 and 4 pi over 3, a good number would be pi over 2, for example. Okay, so substitute that over there. Oh, sorry, 2 pi over 3 is to the left. That's correct. So pi over 2 fits here. You can put pi over here, and between 4 pi over 3 and 2 pi. 4 pi over 3 is downstairs to the third, on the third quadrant. So 3 pi over 2 would be a good example to put over there. Okay, and you get these values. So let me explain again. Try pi over 2 in this. Cosine pi over 2 is 0. You get positive. Here put pi. X is pi. If you put pi, cosine pi is negative 1. Overall you get negative. Here you can plug in x equals 3 pi over 2. Cosine 3 pi over 2 is 0. That gets you a positive. Alright. So what does this say? G prime positive means G is increasing. Here G is decreasing. Here G is increasing again. So what pictorially what this means is G is going up over here, going up and then coming down. So this cut point is going to give me a local max. Whereas the second cut point, look at to the left, I'm going down and then going up. So that will give me a local min. Okay. So you have a local max at 2 pi over 3. Evaluate at G, that is a local max value, and 4 pi over 3 is going to give you a local minimum value. Okay, is simply calculating, substituting in G. All right, the graph looks like this. You are first increasing. This was a cut point. This was a cut point. You have a local max here, local min here, because to the left of 2 pi over 3, G prime is positive. That is, G is increasing. Between these two, G prime is negative. This is decreasing. Here and here, G prime is positive. You are increasing. Okay. Now, second derivative, next video. Okay. Until then, bye.